Welcome to Track 18. This session is labeled Tall Buildings, Other Issues. And as I looked through the subject matter, it appeared that we could call this Design and Engineering Tools to Remake Mumbai. And so I'm pleased to be participating in several sessions today that focus on technical issues. And we have three lively and dynamic speakers that are going to share some of their best practices with us. My name is Mark Garland. I'm from Lewis Builds, Toronto. And actually, just a footnote on Toronto, I'm fortunate to live in one of the bright economic places in North America. The rest of the U.S. and the United States seems to be a bit on its ear. So I'm happy to be in Canada. I'm pleased to introduce Simon Lay. He's a director with WSP Fire. And I believe you're located in London? Yeah. And Simon is notorious for questioning why. And so he's going to tell us about bleeding edge engineering, I think. Thank you, Simon.
Okay, thank you very much, Mark. What I'm going to talk about today is going to make a bit of a suggestion that perhaps one of the ways and some of the ways we've been designing tall buildings traditionally is a bit flawed, potentially dangerously flawed, certainly wasteful, certainly less sustainable than it could be. I'm going to talk about the fire safety issues that come out of that. I'm also going to agree with Mayak Gandhi yesterday, who spoke on behalf of the Remaking of Mumbai Federation. He made the point that the soul of India must be preserved. There was a great point made about how we shouldn't be translating the same buildings from one country to another and just plonking them in Mumbai. I'm going to make a similar case that we shouldn't be using the same building codes and design standards from those other building types and plonking them in Mumbai. I'm not going to try and tell people here and the people of Mumbai what building code they should use. I'm not going to try to tell them that they should follow a certain path. What I'd like to try and do is to inspire Mumbai to create something for itself, something which is appropriate, safe, and responsive to the needs of this city. So I'm going to talk about something called performance-based design. In particular, performance-based design relating to fire safety. This is an explanation of what performance-based design is. It's a little bit wordy, so I think probably to demonstrate it, I'm going to give you an example that's perhaps more structurally related. If you imagine you've got a gorge you want to build a bridge across, nobody starts off by saying, I must have a steel bridge across my gorge. What they do is they think about the different options. They employ an engineer who will think about what the needs are of that bridge, what it needs to carry, what its lifetime needs to be, what its costs are, what the aesthetics need to be, what the program for that bridge is. And then they will come to a conclusion, a design conclusion that is appropriate for the performance it needs to meet. Okay? We would think it would be completely mad to say that every bridge has to be designed the same way. We'd think it would be mad if we said that every tall building had to be designed structurally the same way. And yet, that's exactly what we do with traditional fire codes. We make assumptions that all buildings of a certain type at a certain height are the same, no matter where they're placed, no matter how they're built, no matter how they're going to function. And as a result of that, I think we're creating inappropriate building designs. So, why have I shown a bridge example here? Well, I think it's a simple one to understand. And of course, before we had tall buildings for structural engineers to show off with, bridge design was where it was at. The best structural engineers from previous eras have designed the most fantastic bridges. But now, we apply the same principles to structural design. We design for the performance the building has to meet. And the result of that is we get great innovation in structural design. This is the London Bridge Tower. It has an unusual mix of steel, concrete, steel design as you go up the tower, which takes out the need for mass dampers in the building. It's a great bit of innovation. No one said you had to build a building that was steel, concrete steel. No one said you had to put a mass damper in. What they said was, I don't want it to sway too much, here are the limits, now design a building to match that performance. We do the same thing with structures for seismic design. In fact, if we didn't design buildings performance-based for seismic design, then we'd end up with horrendously over-designed buildings in some areas and badly under-designed buildings in other areas. As a result of adopting a careful performance-based approach to structural design of buildings, we achieve economic success. You couldn't have some of the redevelopments. This is a view from the top of the Burj Khalifa. You couldn't have developments like this in Dubai without economic success. It's wrong to think that people who are funding and building tall buildings have this magical pot of gold and aren't interested in cost savings. Of course we're interested in cost savings. Even though we have the economic problems we have at the moment, even before that, even in places that people think have limitless wealth, like Abu Dhabi and Saudi Arabia, cost is still very, very important. And economics is very, very important, and aesthetic is very, very important. And these things drive things like structural design. And yet still, in so many situations, we don't design on a performance basis for fire safety. Instead, we design to a set of prescriptive, codified rules. And all too often, we're applying codified rules from one country to another country. Even when we design to these prescriptive, codified rules, I'm afraid some of the end results cannot be so good. These buildings were designed in accordance with their local prescriptive requirements at the time. And this is what happens to them in a fire. And there's no point in sitting there saying, well, if we adopt this different prescriptive code, it won't happen. I could show you examples of tall building fires, devastating tall building fires, related to any international building code. It's not that those codes are failing, it's just that there's inherent failure in using that particular approach. The biggest problem with using prescriptive designs, taking a codified approach from one country to another, I think, is a design legacy. Those that heard Anthony Wood talking yesterday morning, he used the Seagram building to illustrate the fact about we shouldn't move architecture from one place to another. We shouldn't just cookie cut building designs. Well, the problem you have is a lot of your international building codes are designed around buildings of this type. This is the Seagram Tower, a seminal piece of building design, beautifully economic, often copied, never bettered in my opinion. But you'll find that buildings of this type, with the direct repetition of floor plate, the simplicity of this building, is the sort of building that standard building codes rely on. Now, the image on the right was taken at a hotel in Delhi. We were working with a client there, and the problem they had is they were an American client, and they couldn't understand how we could have a safe, high-rise hotel building without a pressurization system, because they were looking at a standard international code that said you have to put pressurization systems into the building. I think someone mentioned this morning in one of the sessions about the problems of pressurizing elevator shafts. The Indian code gives you a way around that. In fact, it prefers you not to use pressurization if you can do it. And it says instead put the stairs on the outside of the building. Now that's quite a dramatic structural thing to do. But the reason it says that and the preference for that is because the problems of maintenance, of installation, of construction make pressurization systems very, very hard to design and build in this particular country. And in fact, it's difficult enough to design a pressurization system that will work in America or Britain, let alone working in India where they're less well used, less well understood. And in fact, it's very hard to design a pressurization system that works the day after it's been commissioned. In fact, I very rarely find pressurization systems that work. So instead, you have to find alternative ways around that. And that's what performance-based design is about. It's about saying, not that I have to put a pressurization system in my building, it's about saying, what does a pressurization system have to do? It has to prevent smoke movement. It has to protect firefighters. It has to protect the means of escape. What does it mean to protect the means of escape? It means keeping smoke out for a certain period of time. What does it mean to protect firefighters? It means to protect them for a certain amount of time and achieve certain temperatures. Once you take away the premise that we're going to use a particular system type and instead say, what does the system have to achieve, you're using performance-based design. here in Mumbai, I think you are starting to see a certain architectural style forming. I love the extensive use of cantilevers and big holes in the buildings here. I think it's fantastic. I think the Atelier Tower is a classic sort of current example of that. And there's a lot of people I've met, particularly people who've come from Western countries, who said, it's a terrible abuse, that building. One family in 27 stories. But I suppose, given the land values in Mumbai and given the problems of floor area in Mumbai, they're not taking up any more space on the ground, frankly, than one family would occupy. Sure, they're building this edifice in the sky to celebrate their family. But I love the use of cantilevers and the holes in it. And then you've got the older building there as well on the right, which, again, only has about 30 apartments in it. Now, again, that to many people in the West would seem very, very strange. And these aren't the sorts of buildings that traditional building codes were really designed around. To try and apply a traditional prescriptive building code to this type of building, you have to really bully it and twist it and break it a bit. And when you try and do that in a different country from the place the code was originally intended for, then you start getting some real difficulties. You can make it work on paper, but you're really putting a lot of faith in that original building code and matching the original premises of that building code. What you're doing is assuming safety. What performance-based design is about proving and demonstrating safety. You're not leaving it to chance. You're not leaving it to someone who designed a building code 20 years ago that you're copying. You're actually setting out to prove that you have safety. Yesterday, Anthony Wood mentioned also cities in the sky, and they were talking about this particular design solution for the seaward here in Mumbai. And he asked the question, why don't we build schools that are big high-rise schools? And the answer is you'll find a lot of building codes around the world, traditional building codes, so you can't build high-rise schools. You can't build them more than a couple of floors off the ground. If we're going to build these vertically integrated cities, we need to handle those sorts of questions. And you're not going to find those answers in standard building codes, because no one's been through that design process properly. If you want to build integrated mixed-use buildings, you'll find that very poorly handled in traditional building codes. Traditional building codes tend to pigeonhole buildings into one single type. And when they do talk about mixed-use buildings, they have a habit of saying, well, just adopt the worst case. And so you end up with buildings which have a waste of money, a waste of space within them. And the problem with that isn't just that you don't build the building because it becomes too expensive to build. And it's not that you've just spent too much money. If you took the same budget and applied that money elsewhere in the design, you could either save money or you could make the building safer. You could apply the money appropriately. So performance-based design isn't just about cheating a bit and trying to make things cheaper. It's about using the money appropriately and creating value in buildings. So you want to create these buildings, you can't do it through standard design. But there's a great fear about performance-based design. There's a great phobia about it. I think there's three fundamental phobias. The most significant one is the fear of putting your name to it, the fear of the signature. And I appreciate building code officials who have to sign off buildings. It's their name on a piece of paper, and they're the ones who ultimately may be held up in court if a building is found to be inappropriately designed. And yet they will happily sign off buildings designed to international building codes that they don't know the basis of and that are not appropriate to that particular building. The faith that's put into international prescriptive codes is quite worrying. At least with the performance-based design, that building code official has the opportunity to question that design, to actually dig into the assumptions that you're putting forward as a designer and answer whether or not those assumptions are appropriate. And it becomes a partnership with the building code official, working with them, not against them. Not trying to work around them, not trying to put something up there that's going to amaze them and just flatter them, but working with them to create something together and to gain their trust. There's some opposition that comes in from suppliers of building products. Sometimes they're worried about losing money when we have non-standard design solutions. A lot of design, performance-based design, revolves around, for example, Phil mentioned taking out fire protection products. Well, having standardized building products hasn't stopped the structural engineering community from working together with those people, and nor should it in terms of fire safety. And in fact, performance-based design opens the door to many more innovative and new fire safety products. We hear people talking about lift evacuation, elevator evacuation. We hear people talking about innovative suppression systems. All of that is only possible through performance-based design, because there's a long lag between new technology and its application to building codes. That's a necessary lag, but it stops us using sometimes the best international products available. And there is just a simple fear of change itself, just fear of the unknown. And I'm afraid that can only be resolved through education, support, and working together with code officials, other engineers, and designers. So many times where I've carried out a performance-based design, the local engineer will be worried because they haven't understood it. And it's very easy for an engineer who's used to working in this sort of design to stand up and say, well, clearly that person isn't educated enough, or that person hasn't understood what I say. My response to anybody in that position is that if someone hasn't understood what you're saying in your design, that's your problem, not theirs. Okay? You should be able to break performance-based design down into very, very simple building blocks and explain each individual block. If you can't do that, you're not doing it right. Now, I've given international codes a bit of a knocking, saying they're probably the wrong way to design buildings. In fact, the international code community have responded to performance-based design brilliantly. You'll find in the latest versions of the NFPA code, the International Building Code, you'll find performance-based design options within there. My personal preference is that actually the standard code approach should be one of the end solutions from the performance-based design rather than the base version. And I know that's something that NFPA, for example, are looking at, they may introduce, that you should look at all the building risks before you start applying the standard solutions. In the UK, we've had the approved document B, which is our standard prescriptive guidance, but it specifically says you shouldn't use that for large and complex buildings, and that performance-based design is what you should be doing for those sorts of buildings. Anybody who thinks you can't use performance-based design in China, I'm afraid that's wrong. You can use performance-based design in China, and I'll show an example of a performance-based design building from China in a minute. And there are countries like Korea who are entering into major building programs at the moment, and they've recognized that actually it's the only way of designing tall and complex buildings is to use performance-based design. And they've taken a very good analogy from the semiconductor industry, where they applied a lot of prescriptive legislation, and it slowed down the development and the innovation in that industry. And when they applied that to tall building design, they turned around and said, we need to free up tall building design from prescriptive codes. We need to introduce innovation that frees up the buildings and allows them to be created. And very soon, you will have to adopt a performance-based design for fire safety of tall buildings in Korea. And I think that's a fantastic step. So, tall building design, in terms of performance-based design and fire safety, it really comes down to three very simple words. The performance you're trying to achieve is to make the building safe. Make it safe. If anybody wants to sum up performance-based legislation in terms of fire safety, that's a very simple summary of it. But then we break that down. What does making it safe actually mean? And it means meeting a certain number of what we call functional criteria. And the first one's about preventing fires happening. You often won't see that written down in prescriptive codes. They tend to shy away from the operational relationship between design and fire safety. You can have to talk about things like limiting fire spread, ensuring that evacuation works, supporting firefighting activities. And if we take one of those, which is evacuation, then we can break that down further, and I'll show you that in a second. But the interesting thing about performance-based design is that you won't find much discussion about property protection in most standard building codes, and yet it's very important. We talk about sustainable design. Well, stopping buildings from burning down and having to be replaced is a functional objective that you can place. We talk about business continuity. Very, very important, particularly when we start talking about mixed-use commercial buildings. Security is a very important requirement, and it often clashes with fire safety requirements. If you use a performance-based approach, it becomes one of the things that you're trying to meet. It becomes another item on the list that you assess it against. It was mentioned earlier in the vertical transportation discussions about how we should have integrated design between different designers working together. And that's what performance-based design allows. It allows everybody to have a contribution to the design process, rather than everybody designing in isolation to their own separate little codes and then trying to cobble it all together at the end, often on site. So if we break the evacuation one down a little bit further, we start getting down to things you can actually measure, things you can calculate. You can calculate how long it takes to escape and calculate how long before conditions in a fire compartment become untenable. And we're no worse at calculating that than we are at calculating structural stability. And yes, we apply safety margins and safety factors. But the beauty about performance-based design is that we can start trying out different solutions to extend those times to untenable conditions or to reduce the evacuation time. We can try out diverse different solutions. I can compare mechanical smoke exhaust and pressurization to adding sprinklers or more compartmentation. I can compare lift evacuation or elevator evacuation to pressurization as two alternatives in a building, two completely different mechanical systems. But using performance-based design, I can compare those options. I can also, very importantly, take into account the reliability of those systems and whether we think they're actually going to work in practice. And then you start to see some very interesting solutions. And one of the most interesting things in performance-based design is the evolution of risk-based design, which has been around in the petrochemical and the nuclear industry for a long time, and we're starting to apply it to actual building designs by comparing diverse systems using numerical risk-based probabilistic analyses. So what does a performance-based design building look like? I should really stop using this example and start bringing out some more recent ones, because I've got plenty of them. But it's a nice building, it's fully built out, and whenever we talk at the Ctbuh, it did win the Ctbuh Best International Tall Building Award, so it's quite nice to roll it out. When we designed this building, it was started just after 9/11, and everyone was challenging what were the fire safety requirements for tall buildings. There was a huge shift going on. Some people were saying we shouldn't even build tall buildings. Some people were saying we must put 3 staircases in. Some people were saying we must put 4 staircases in and 2 hours and 4 hours fire protection. So our client got a bit nervous, their investors got very nervous, and the approval authorities got really nervous about what they were going to approve. They didn't want us to stick to a standard building code. What we did was sit down with the code officials, the users, and other technical people to actually work out what were the real risks in the building. What were the barriers to achieving making it safe? And one by one, we addressed those particular requirements in an integrated design solution. As a result of those analyses, we ended up with some very interesting design solutions. In particular, the fact that the top half of the building has a single escape core. Okay? It has one staircase, and it's a 50-story building. Even more remarkable, perhaps, is the fact that it does that without having sprinklers in the top half of the building. And we're able to achieve that by a great synergy between the structural design and the fire safety design that gave us superb quality compartmentation in the building and some very careful design of the slab edge details so the facade fire spread wasn't a problem for us. At the same time, we took out pressurization from the tower and put in an alternative ventilation solution that was both more economic, it took up less area, it's more robust as well. It doesn't rely on the building envelope leakage paths, etc., to make the pressurization work. It uses installed shafts instead. It's also a system which, if the mechanical fans fail, it still has a natural component, providing about 70% of the ventilation. So it's a much more robust solution than traditional pressurization, which was also a lot easier to design. We could design that system without having to worry about a lot of the details of the actual final building construction. So it gave us great cost certainty very early on in the building design. Putting all these things together, we were able to design a building where, if we did get fire spread between floors, the fire service could still clear those floors of smoke. And you won't find those sort of requirements in standard building codes. We gave the fire service a building where they could flexibly fight fires in different locations. We designed a building for occupants that if they wanted to stay in the building, which was actually the safest thing to do in this particular case, they could do so. But if they decided to evacuate, they could also evacuate. Designing for those two different criteria. And the standard building code actually in the UK would have assumed that everybody stayed in the building, would even cover the possibility of people deciding to evacuate. That's one of the big questions that came up after 9/11, about people not being prepared to stay in tall buildings when they're on fire. So we had to address all of those. And the only way of doing that was through performance-based design, setting ourselves a set of key targets, key challenges that could be addressed through detailed analyses. I said I mentioned a version in China. This is the China Poly building in China, designed by SOM. It's a fantastic building. It has a 13-story mini building suspended within the main building via those sort of steel cable areas you can see here. Now, those are steel cables holding up a building inside another building. Good luck trying to find a fire resistance product that can actually protect that to achieve the 2 hours fire resistance that was being asked. The only way to actually make that building work was to use a performance-based design approach, to look at what the real fire risks were, to understand what the implications on the steel cable were from them being hot, and to design around that particular problem. At the same time, it has a very large, very tall atrium space, and we performance-based designed the smoke ventilation system and the facade system in there to prevent fire spread, but also to produce a more economical solution. And that's done in China. A lot of people say you can't do performance-based design in China. Rubbish. Of course you can. How you implement performance-based design, particularly in a country where you haven't used it extensively, could be quite difficult. And there's 3 different models there, one from the UK, one from Singapore, and one from Hong Kong. So there are different ways, different flowcharts you can put forward for actually achieving performance-based design. But the main thing is about creating a trust between the approval authorities and engineers. A trust that performance-based design engineers are not trying to pull the wool over their eyes. That actually we're giving the approval authorities the opportunity to question design, but coming to those questions with the answers already prepared. For a city like Mumbai, that's embarking on a major regeneration program, we heard a lot yesterday about infrastructure and the challenges of infrastructure, how we deal with those problems in the city. And I saw some great ambitious plans with some quite long dates on them. And I'm quite sure that Mumbai will put in place all of the infrastructure that's expected before it builds some of these tall buildings. But if it doesn't, if someone could show me a traditional prescriptive building code that assumes that the streets are clogged with traffic, like in that picture on the right, or that the buildings you're dealing with may be surrounded by buildings like those from Dharavi on the left, then I'll be very impressed to see that particular code. So Mumbai should be thinking about a performance-based building code approach as an umbrella term for a lot of the redevelopment sites. And then for each individual site, looking at the individual risks, the individual challenges about those individual sites, and creating building designs that actually relieve the pressure on the infrastructure. That can be done, and it's being done in places like Dubai and Abu Dhabi, where there are city-scale projects currently being planned or under construction, where whole site fire codes using performance-based approaches are being applied, and they're being applied very successfully. So that approach can work. It can deliver cost savings, but better safety at the same time. Thank you.